If n and t are positive integers, what is the greatest prime factor of the product n times t? So the product n times t is just going to contain all of the factors of n and all the factors of t. So if we can find what the factors of are of our individual terms, then we should be able to determine what the greatest prime factor of the product is. But without knowing anything more about n and t, we got to look at our statement. So statement 1 says the greatest common factor of n and t is 5. So if we organize our information into a table, we need an n, we need a t, we need our n times t, and then we got to figure out what is the greatest prime factor of n times t. So what is statement 1 saying? If it says the greatest common factor of n and t is 5, that just means each of them contains a 5, and that 5 is the greatest one that they have in common. But it still means we can have other factors, and we can have other factors greater than 5. It's just not going to be shared between both of our variables. So let's say, for example, so let's keep this example. So let's say n is 5 and t is 5. It doesn't say anywhere they can't be equal to each other. So in this case, n times t is just going to contain 2 5s. So I'll write n times t is just what its factors are. And so in this case, the greatest prime factor is just going to be 5, because those are the only factors of n times t. But let's say I add a 7 to my n, so n is equal to 35. So now n will contain a 5 and a 7, t will still contain a 5, and so n times t will contain 2 5s and a 7, and so now the greatest prime factor is 7, so this is insufficient. Statement 2 says the least common multiple of n and t is 105. So if we even forget for a second about the this least common part, we have a multiple of n and t that is 105. So what does that mean? So a multiple of two numbers is going to contain all of the factors of those numbers. So the greatest prime factor of n and t is just going to be contained within our 105, because 105 contains all of our factors of n and t. And the fact that it's the least common multiple means at a minimum, n and t must contain all of these factors. So what are those factors? 105 can be broken up into 21 times 5. And 21 can be broken up into 3 times 7. So our greatest prime factor here should always be 7. So let's see if we can prove this maybe by testing some numbers like we did for A. So let's say, for example, n is equal to 21, and 21 is just a 3 and a 7. And t is equal to 5. So the least common multiple of 21 and 5 should be 105, so that checks out. And then n times t is just going to contain all of our factors of n and t, so 3, 7, and 5, which means our greatest prime factor is 7. Let's say n and t is, let's say if it's 21 and 105. So 21 is 3 and 7 again. 105 is just 3, 7, and 5. So let's just write it like that. So n times t will contain 2 3s, a 5, and 2 7s. So these are just duplicates of the factors of 105. So that's really what we're saying here is at a minimum, we just got to contain all of these factors. We don't necessarily know how much we have of those, but it's still going to be 7 is the greatest prime factor. Doesn't matter if we have, 3 3s or 5 5s and 1 7. The number doesn't matter. It's just the amount that matters. And so this is always going to be the case, and that's because of the least common multiple of n and t is 105. That means at a minimum, n and t has to contain all of the factors of 105, so 3, 5, and 7. Anyway, so the answer, sorry, forgot to answer the question, B.